Dear students, in this session we will discuss some practical aspects of hypothesis testing. It is a concluding session about hypothesis testing by considering a few issues associated with the hypothesis testing procedure. The first issue we consider is the meaning of accepting or rejecting HCR. What is meant by accepting or rejecting a hypothesis? Suppose that on the basis of a test of significance, Z or T, we decided to accept H0. Remember that if we reject H0, then we are sure that we are rejecting a false hypothesis, because the probability that the hypothesis is true is only 5%. But if we accept H0, we do not know what is the probability of accepting a false H0. So when we accept H0, all what we say is, on the basis of sample evidence, there is no reason to reject it. On the basis of sample evidence, there is no reason to reject it. So we are not saying that H0 is true beyond any doubt. So when H0 is not rejected, what we say, we fail to reject H0 at 5% level or 10% level, 1% level, etc. Rather than H0 is accepted at 1%, 5% or 10%. And remember this is a very important point. We said we fail to reject H0 rather than we accept H0, or we may accept H0 rather than we do accept H0. Just as a court says, not found guilty rather than innocent. If you reject H0, then we are sure that we are rejecting a false hypothesis. Our decision is correct 95 out of 100 times. So there is no problem. The problem is when we accept H0, we do not know whether we are accepting a false hypothesis or a true hypothesis. If a court gives a punishment to a person, he is rejecting H0. The court has found that he is guilty. So the court is sure that punishment is given to a guilty person, that is H0 is correct and the decision is also correct. The second issue is how to form H0 and H1. How to form H0 and H1. And there are no hard and fast rules regarding how to formulate H0 and H1. Formulation of H0 and H1 is based on the issue at hand. As we have discussed, the problem will give you guidelines about how to form H0 and H1. But keep it in mind the fact that before you enter into a research program, you must first fix hypothesis. If you fix a hypothesis, after observing the results, you can always justify your results. That is, suppose that in a study you obtain x bar as equal to 50. You fix a mu as equal to say 51 or 94, close to, then H0 will be accepted. But the test is not significant. So you fix a mu as far away from 50, say 40 or 60, then H0 will be rejected. That means you can formulate H0 in such a way that it is always rejected. If you formulate a hypothesis after observing the results. That is the second point to be kept in mind. The third point is how to fix alpha, the level of significance. Level of significance. Actually, the weakest point of the classical hypothesis testing procedure is arbitrariness in fixing alpha. Alpha is arbitrarily fixed at 1%, 5%, 10%, etc. And alpha is the level of significance, and it is the probability of type 1 error. What is the logic of fixing alpha at 1%, 5%, 10%, etc.? There is nothing sacrosanct about these values as values. And regarding this fixing of alpha, as I told you, if alpha decreases, probability of type 1 error decreases, but beta increases, probability of type 2 error increases. As we have discussed earlier, fixing alpha depends on the relative cost of type 1 and type 2 errors. Type 1 and type 2 errors. In the case of how the steel is used, an example we have considered. And as one author says, if the error of rejecting H0, which is in fact true, that is type 1 error, is costly relative to the error of not rejecting H0 when in fact it is false, that is type 2 error, it will be rational to set probability of first kind of error low. So if the probability, if type 1 error is costly than type 2 error, fix alpha at a very low level. On the other hand, if the cost of making type 1 error is low relative to the cost of type 2 error, it is better to fix the first kind of error, alpha high, because cost of type 1 error is low. So there is no hard and fast rules regarding how to fix alpha. It depends on the cost of type 1 error and type 2 errors. But the problem is we rarely know the cost of making type 1 and type 2 errors. So applied statisticians fix alpha at 1%, 5%, 10%, etc. and try to reduce the probability of type 2 error. And the procedure we have discussed, an increase in the sample size will always reduce the probability of type 2 error and increase the sample size. The third issue that we have discussed is exact level of significance. That is the p-value. Remember this, in applied statistics, the modern practice is to report p-values rather than fixing alpha arbitrarily at 1%, 5%, etc. You conduct a testing procedure, you will get a test statistics from the sample Z or T, Z or T, then report the probability of obtaining this Z or T. So it may be 0.01, 0.05, 0.10 or 0.001, 0.005, etc., etc. Let the reader decide whether to reject H0 at 1%, 5% or 10% level. Give a chance, a discretion to the reader also to decide whether to accept or reject H0. and p-value is also known as the exact level of significance, the lowest level of significance at which a null hypothesis is rejected. In the age of computers, if you have an z is equal to say 100, you will get a p as equal to 0.001, 000, because the probability is very low. So we cannot say that H0 is rejected at 1%, because it is not it is not 1%, it is much lower than 1%. So you report p-value, the exact level of significance. Now, in the context of hypothesis testing, remember this, there are two approaches to hypothesis testing. One is the confidence interval approach, and second is test of significance approach. We have discussed earlier how to construct confidence intervals. If you want to use confidence interval approach to hypothesis testing, what we do is construct the confidence interval, the procedure we have discussed in detail, and see whether the hypothesized value is in the interval or not. Suppose the interval is between 50 and 100, and the hypothesized value is, say, for example, 60. H0 is accepted. If hypothesized value is 110, H0 is rejected. If it is in the confidence interval, H0 is accepted, the test is not significant. Otherwise, it is significant. Because we know that the parameter will lie in such intervals 95 out of 100 times. So what we have discussed in detail is the test of significance approach. It is based on a test statistics, and the sampling distribution of the test statistics is under H0. That we have discussed in detail. Now, in the confidence interval approach, what we do is we establish a range that has a certain probability of including mu. We establish a range, and we say that this range will include mu, certain probability, say 95%. In the test of significance approach, we hypothesize a value. We hypothesize a value, say mu is equal to 10, like that, and we try to see whether the value of x bar obtained from the sample is reasonably close to hypothesized value. If this is the distribution of x bar, mu is 10, and we compare the value of x bar and see whether this is close to this. And we can use either the confidence interval approach or test of significance approach. Both will give identical results. You will never get a contradictory results. And remember this, in the language of significance tests, a statistics is said to be significant if and only if the value of the test statistics lie in the critical region. That is, null hypothesis is rejected, and a test is said to be statistically not significant, insignificant, if the value of the test statistics lie in the acceptance region. In that case, H0 is accepted. If another issue that we consider is statistical significance versus practical significance. Statistical significance versus practical significance. Suppose that on the basis of a hypothesis test, H0 is rejected. And when H0 is rejected, we will say that the test is statistically significant. That is, statistical significance means data provides sufficient evidence to conclude that the truth is different from H0. However, it is not necessary that it will be practically significant. To explain the difference between these two, consider again the hypothesis H0 mu is equal to 26, H1 mu is less than 26. And suppose n is equal to 1000, x bar is equal to 25.9, sigma is 1.4, z is minus 2.26, and at alpha 5%, H0 is rejected. H0 is rejected means the true mileage is less than 26, maybe 25, because our value is x bar. Our sample is very below the 1000, x bar may be close to parameter, so 25.9 is mean. So statistically, the procedure says that the test is significant statistically, but practically it is not significant because 26 is not much different from 25.9. So even though the test statistics is, or the procedure is statistically significant, it is not practically significant. So always keep in mind the difference between statistical significance and practical significance. So these are some of the problems, some of the issues, some of the concepts which you will keep in mind while undertaking a research study and hypothesis testing.